Okay, we're on. Good afternoon. Thank you for being here. The room is small enough that we really don't need microphones. However, the session's being recorded, so for the benefit of the recording, we'll go ahead and use them. Hi, Talia. My name is Tim Mather. I am with PatternEx, recently joined. I've been in security for a long time here in the Valley. We're going to talk about the subject, or one of the two subjects that you cannot miss in the newspapers these days when it comes to cybersecurity. One of them, of course, is ransomware, and the other one is artificial intelligence. And we're going to talk specifically today about artificial intelligence and applying that to information security. Why would we want to do that? What are the goals, et cetera? So with me, Yoav, and Yoav heads up his own venture capital firm, Weil Ventures. Yoav, you want to take just a second and say something about yourself, please?
Sure. Absolutely. Can you hear me? Yeah. So we, Weil Ventures, we've been around for almost a decade now. Can't believe it. We're almost into our third fund, and we make early stage investments. Nowadays, it's typically $2 to $3 million at seed. Cybersecurity is our biggest sector. We have five. We had six. We now have five cybersecurity companies active in the portfolio. Our model is typically to invest in Israel at seed, and then bring the companies over here, at least the CEOs, and do A rounds, B rounds over here, recruit management teams, really help the companies all the way to exit. I guess I should mention we sold a cybersecurity company a couple weeks ago called FireLayers, which went through the full cycle in 3 years. But we also invest in other areas. We just sold a company called BlazeBeater as well, which is in the DevOps space. Anyway, that's enough about us. We do look. We have a lot of exposure into AI, especially as it comes to as it relates to cybersecurity. You're going to hear about why AI is so important for cybersecurity. So I'm very happy to be on this panel and honored to be speaking next to Uday here.
Uday, say a little bit about yourself, please.
Hi everyone. My name is Uday Veeramachneni. I'm a co-founder, CEO of PatternEx. So we founded about 3 years ago. Our goal is essentially to create an AI platform for cybersecurity, and primarily focused on solving the detection problem. So one of the people ask me, like, how did you start, and what was sort of the founding premise for the company? It was fairly simple. I used to manage firewall products before, and one of the things that I learned over the years is that most of the attacks that you hear of, or our customers used to call us, a lot of the times the data is actually there. The firewalls miss the attack, or the existing security infrastructure misses those attacks, but the data to figure out who came in, what they took, or how they took it is always there, right? And humans go in after the fact, and they're able to figure out exactly what happened, right? So to me, that was, okay, if data is there and humans are able to figure it out, can we solve this problem in real time? Can we create something that can actually detect these things in real time? So that was the founding premise for PatternEx. That's what we've been working on for 3 years. We launched earlier this year, and we have a GA product at this stage. Thanks.
Great. And I will just add, questions from the audience are encouraged, so please ask your questions. Let's start with the basic one, please. Uday, artificial intelligence versus machine learning, what's the difference? Make sure that we're all on the same page here.
Okay, yeah, I mean, that's a very tough question. So there's a lot of language around machine learning in security. So one of the ways that we talk about AI is, can you actually mimic the human? Generally security has two components today. There's the infrastructure, which is firewalls, SIEMs, IDSs, IPSs, and things like that. Then there are humans that are going through the alerts that are coming out of those systems, right? So the core purpose of any system that's claiming AI is that, can it mimic those security analysts, right? Can it, like, if it says something, is it what a security analyst would say? Yeah, if I had looked at it, I would have said the same thing, right? So that's what we would call as AI. And if you go to Gartner and how they define AI, is basically a system that can learn from humans and is able to give them back something that they couldn't have achieved themselves, by themselves, right? So that's the pure definition of AI.
And so what's the goal of applying AI to information security?
So the goal's fairly simple at a high level. It's obviously very complex to, when you get down to nuts and bolts. The goal is to basically mimic those security analysts. So today you have all the security infrastructure that's generating alerts, and you have analysts that go through that. And a lot of times what happens is they're very inefficient in the sense that the alerts that are coming are usually noise, and analysts chase them down, and they end up being false positives. So in cybersecurity, the goal is essentially to have a system that is able to change that ratio of true positives to false positives, and be able to complement and learn from an analyst and complement an analyst to increase his detection ratio.
So are there any security practitioners in the room? A couple. Okay, very good. So you know what the problem is. The problem is twofold. Number one, there's too many false positives. The noise level is too high. We've had this problem with intrusion detection systems for years, and now we've got it from other devices as well. So how do you get that false positive problem down? Some people will use some sort of filtering to just try and say, I'm going to reduce the noise that way. Well, if the bad guys have got a clue, then they'll just hide within the filtering, so you are not even looking at that. So false positives is one, and the other one, of course, is false negatives, how much stuff is actually missed. If you look at the Mandiant M-Trends report and look at as they've termed it, the dwell time or the compromise time, it's pretty embarrassing. Okay, I do information security for a living, and I'm not proud of the fact that the average compromise time is over 200 days. Okay, there are several companies that have publicly admitted, the New York Times being one of them, that they were owned by Russian hackers for more than 2 years. And they didn't even catch it. Someone else caught it and brought it to their attention. Probably the worst example is someone who's no longer here because they were compromised. Nortel Networks was compromised for 10 years and didn't even know it. Okay? So false negatives, obviously a huge problem. False positives and getting rid of that noise so the analysts can actually look for something that's real is really what the goal is all about here. So how you get to that is what we're trying to do. So Yoav, from your investment perspective, what are you looking for here, please?
Sure. So maybe just to kind of continue on the thread that you started there, I think that AI can be applied in cybersecurity in several different areas. And where Tim was spending most of his time right now explaining was, I think, a lot on the response side of cybersecurity. So, basically incidents that are, or vulnerabilities that are being taken advantage of in your network, hackers that are currently owning you, currently penetrated and active in your network, and it's a matter of, it's a matter of responding, basically, and remediating, analyzing and remediating security incidents. Now that takes a long time, and it's something that still today is typically done by human beings. It's very time consuming. It's literally like finding needles in haystacks. You got to look through hundreds of log files, and other bits of data in order to find clues. Piece it all together, and then find a common thread through that. Translate that into actionable intelligence, and then do something about that. And that's getting harder and harder to do. Actually, people like Uday and companies like that are really trying to, make that much more efficient process. Basically, making sure that humans are doing a smaller percentage of that, and letting machines do more of that through the use of AI. We have a portfolio company, I don't mind mentioning it here, I think Tim doesn't mind either, a company called Hexadite, which also has a different take on the same problem, but also using things like AI in order to bring machines into the mix and help with incidents. So that's an area that we're very, very interested in. There's also other areas where AI is applied that's interesting for us as well. For example, in just the pure detection space. So before you're even investigating an alert, before you're remediating an alert, just the very initial detection, which there's companies that do that, like your antivirus software on your PC, or FireEye, or SecAlert, or any of the other detection systems. There's more and more AI that's applied there. Traditionally, say 10, 15 years ago, detection was mainly based on signatures. So basically cataloging what all the viruses or malware look like, their hash, what do their files look like, and then looking for instances of those in desktops, servers, mobiles, wherever else. Today, that doesn't work anymore because malware morphs itself and changes all the time. You can't do signature-based detection really anymore, and so I think AI really comes into play. You're basically looking at the problem like a human does. You're trying to figure out what are the characteristics, the traits, the features that make this a malware. You look through lots and lots of data and try to find the correlations and the pinpointed intelligence that'll point to malware. So AI is really on the upward trend in lots of different areas of security. I'll stop there.
Yeah, so signatures are dead. I think everyone knows that by now. The traditional anti-malware vendors are having trouble keeping themselves afloat, if you will, off of that. It's part of the reason why companies like Cylance are doing quite well up against the traditional Symantec, don't call us McAfee, Intel Security, Trend Micro, et cetera. So that's dead. You can't do anything static like a signature, so I need to find something that is more dynamic in the approach. So Uday, how does this find, and from a non-signature status or perspective, how does AI help with that process?
Yeah, so couple of things before you sort of get into AI is people have traditionally used rule-based systems, like what Tim mentioned. One form of that is signatures, and the alerts come out of those rules, and people investigate that. So, and those rules are fairly static, so attackers figure that out and they work around those rules and get in, right? So the second step to that is people said, okay, how about I let people extract analytics, create analytics dashboards and things like that. So Splunk is very good at that. If you know what analytics you want to look at, it'll let you create those, right? And you can look at that and investigate. Now, where sort of what AI does is on top of that. Now you're like if you want to do rules, that's static. Somebody creates it, nothing changes, and people get in, right? The second step is if you know what you want to look for, you can use analytics. So that's where Splunk comes in. Now, if you don't know what you're looking for, and attackers are continuously morphing. So now, you're trying to figure out, you have 5 million, let's say 5 million events in your org, and there are 50 that are roughly, that's the rough ratio of what you'll find in an organization that are malicious, right? So you want to go from those 5 million events to those 50 or maybe even 10, right? So how do you get there? Like, what are you trying to look for? So that's where sort of AI comes in, where it takes all the logs, it'll extract all the analytics that you're used to through Splunk. So that's step one. But so then that's sort of the input to the AI process, right? So from that point on, AI tries to figure out, okay, given this population of 50 million events, what stands out? Like, what is an outlier, right? And again, a lot of people stop there. In security industry, people just do what's called an outlier analysis, and they just stop there, right? But that's statistical in nature. I'm looking at a room full of people, and I'm saying roughly the height is, between 5 feet and 6 feet. So anybody with 8 feet is an outlier, right? But just because someone's 8 feet tall, it doesn't imply that he's a thief, right? So, but what I'm trying to say is outlier analysis is the first step towards figuring out what's rare in your environment, right? But that's not sufficient. That's not enough to say that I've caught those 50 events that I'm trying to get to. So and it has a lot of false positives. So the second step there is then you ask the human analyst to say, okay, what do you think of these 50 outliers that I've caught? Right? He may say, look, these 2 are malicious, and they are attack number 25 or whatever he wants to call them, right? The other 48 are normal. So you take that feedback back. The AI system will take that feedback and sort of now go back and figure out okay, what pattern exists in this data to say that, okay, the next time I'm going to see that pattern, I'm going to call it attack number, whatever the analyst called it, right? So in that sense, now it's created a behavioral signature, not a static signature, but a behavioral signature in your data that now it's able to figure out, if I come across this behavioral signature, I know that the analyst is going to call it attack number 25, right? So that's how AI works in this. So SIMs have done the rule-based systems for a long time. I mean, they produce a lot of the stuff that are just false positives. So you have a question?
Question in the back?
Yeah, so I was just wrapping up. So then you have Splunk, which is sort of does more advanced analytics. AI is the next step where you're going back into the data and you're trying to figure out, okay, are there patterns here that exist that are accurate predictors of threats?
So I think, I mean, I at least will not argue with the fact that rule-based, pattern-based is dead. What I haven't seen so far, and I don't know what you guys are seeing, are a couple of things, a couple of challenges, and I didn't see good solutions. The first one is the signal-to-noise ratio is really not that good. So even identifying kind of whatever system you use, neural nets, deep learning, AI, identifying dynamic patterns or doing any classification becomes very hard. The second problem is that it's very hard to come up with a good training set. So if you try to do any supervised learning, I don't know where the data is coming from. The question is, how do you guys solve the problems, or what do you see as solutions that will turn the hype into actual reality? Because I'd love to have a large-scale AI system that detects new security problems.
Right. Okay.
So let's start with the last point first, if I may, please. And that is a key problem, a major challenge for security companies is, where do you get a large set of data that contains dirt, if you will, that I can actually test on and ensure my product works? Say louder, please. Correct, can't look back. So there's only 2 of those data sets that exist in the United States for, that the US government makes access to, that's it. So finding large-scale data sets to train and to test on is a significant problem, absolutely. Which is why you've got to, frankly, get a customer to hopefully turn over those logs to you so you can analyze off of those, because that's the only way you're going to get it. Otherwise, you're in trouble off of that. So as with regards to the signal-to-noise ratio, yes, significant problem, and in fact, that is the false positive issue that we talked about earlier. Now, the problem is worse than that, because in a large enterprise, you're probably logging or collecting the logs, aggregating the logs, and putting them through a SIM-type product with maybe, what, 40% of your data? You probably don't even have all your security data in there. You probably don't have, but a fraction of your operational data. You probably have even less application level data, and there's certain data that you're never going to put into a SIM-like product. For example, think of flow data and think of email. So those of you, any Splunk customers in the room? Okay, 1 or 2. Okay, you know how Splunk licenses. Okay, it's by the volume of data that is ingested and indexed. So if you were to put flow data and email into Splunk, you just blow the roof, okay, as far as your price is concerned. So that is a significant problem, absolutely. Want to add?
Yeah,
please?
I want to mention that.
Pardon me. Thank you for your question. You can have a free candy bar next to you there, please.
I want to point out that for startups specifically, that is actually sort of the number 1 and number 2 problem. So for early stage startups that come to us with AI solutions in the security space, the biggest problem is that they have no evidence that that what they're developing actually works, and the reason they don't have evidence, or the reason they don't have enough mileage with their solutions, is because they have no access to data. That is one of the top 3 problems, and there's no way for them to get it. It's really there are very, very few large organizations, if at all, that are willing to share, this the quantity of data that's required and the quality of data that's required in order to really train these AI algorithms and to actually prove something. I'm actually interested, how do you guys get your data?
Yeah, so that's actually a very, very good question. So the AI has its own challenges, but when it comes to cybersecurity, those challenges are, sort of a much higher order. And one of them that you listed is what we call as training sets or labels, or, the problem is cybersecurity is a thin label space problem where you don't have enough labels. Right? You walk into a Fortune 500 company, you'll get, like I was saying, 50 million events, and in reality, there are only 50 threats, right, that happen on any given day. And even those 50, those people, the security organization doesn't know. So you don't have the labels, right? So that's actually a very, very active research area at this point. And people have developed early systems. We are one of them. And you can just Google it. It's called thin label space. People have created systems that can work on those thin label spaces. So we can deploy, and I'll answer both your questions. The first one was thin label space. So on that, we can deploy an AI model on just 20 labels. Right? If I get 20 labels of any type, right, we can create a model with reasonable efficacy that'll be much better than any other existing system that you have. So that we can show value to the customer, right? So that's the first thing.
Pardon me, for sake of the audience, define label, please.
So label is what he was mentioning, right? Like, given an event, do you know whether it's an attack or not? And has it systematically been captured by your, whatever industry you're in? Is it, like if you go to, for example, image recognition, right? People, build image recognition software that can, detect chairs versus tables. Now, there are billions of examples of chairs and billions of examples of tables, right? Those are labeled examples. Some human has looked at it and said, that's a chair, right? Or that's a table. Now, the machine can take that and now figure out, okay, how does a chair differentiate against a table, right? So that's what AI is all about. It's trying to take what humans have said before and trying to generalize that and being able to, deploy that on the incoming data, right? So in security, that doesn't exist. In security, there are no labels. There's no systematic way of capturing these things. AV vendors have done some, but that's very sort of contained niche data sets, right? So the problem is SIM vendors have never done this kind of stuff. So when you walk into an organization, they have no training sets. So if I go in and say I'm going to deploy AI, it's like good luck with it, right? So that's the fundamental problem in cybersecurity. Therefore, not any company that says machine learning is going to be able to succeed, because you have to essentially solve the thin label problem. Right? There's very thin labels, very less amount of labels in cybersecurity.
But it's not only malicious data that needs to be labeled. Labeling benign data or good data is also important. Yeah, you want to be able to tell what the good patterns are as well as the bad patterns.
It's absolutely critical that because see, good data is also a label from an AI perspective, right? From AI perspective, given a new event, I have to say whether this is normal or it's an attack. So I need to have examples of both that I should have learned from. If I have only one, then I'm going to produce garbage in another one.
It's actually a lot harder than that because it's contextual as well. It's all about who's trying to access what kind of data under what circumstances. You can't make a decision without the right context. I said it's harder than that because it's contextual. What one person in a company is trying to access may be completely appropriate in a different individual it may not be, in their location and the device they're using. So you can't even say just kind of looking at patterns is enough. You have to have an identity context potentially that goes around it.
So that again is a context that you're feeding into AI, right? So it's what kind of data you feed in will dictate how efficient your AI, how quickly your AI gets efficient. So for me, like what you said implies that I need to have maybe organization of the person as an input. I need to have location of his location, or the distance travel between the time he logs in. All those things are sort of what we call as behaviors or features or analytics, or those things become an input to the system.
But the point is very correct in the fact that you need multiple entities on which to determine then to apply the label against that behavior.
Yeah, and there was another question there, which was how do you, the sort of the other problem in cybersecurity is even if you figure out how to predict a certain kind of attack, the attacker morphs. Because remember, there are humans attacking from the other side, right? So if they figure out that you've detected them, they're going to change. So how does sort of AI morph? So that's the second challenge in cybersecurity. So in image recognition, for example, if I create software that detects tables, the table's not going to change tomorrow, right? I'm going to detect black table, white table, gray table, whatever it is, right? But in cybersecurity, the attack lifecycle itself changes. So, and that's where like deploying static AI or static models that AV vendors do is not going to work. So you have to be at the customer side, engaging with their analysts, trying to figure out what they're saying and what they're seeing as evolving threats, and being able to bring in all kinds of data into your system and show threats.
I think something important to point out is that attackers are actually using AI now. So it's not just thinking about AI as a defense tool for the cybersecurity community. It's almost like we're already behind. We know for sure that the threat actors are using it against us, and it's almost like we're playing catch up in a way. We actually need AI just to fight AI. Just on that basic level.
Yeah, if you haven't seen it, there's a very good presentation up on YouTube from Black Hat last year, 2015. And as I recall, the title is something to the effect of what your security vendor is not telling you about machine learning. And they actually demonstrate using machine learning in a negative sense, if you will, to defeat anti-malware, even if anti-malware that's developed with AI. It's quite interesting, so I would go take a look at that if you want.
And of course, like you all were saying that one of the fundamental problems as a startup is how do you get access to the data? So what we've found is getting access to raw data is actually not that problematic. I mean, if you've been in the industry long enough, you know enough people, enough friends, you can pull through some data sets. But the problem is you don't get labeled data sets. You don't get enough labels or enough training sets to be able to deploy productively. So that's where you have to go back to the customer, engage their analysts to get labels, right? And that's actually it took us a long time. It's very hard. It's much harder for a startup to do it.
Yeah. Go ahead, Tim.
So I was going to say, so speaking of startups in this space, if you go onto Angel's List and put in companies, search by security, search by analytics or whatever, even those that are known to Angel's List, it's 110 companies, or was when I looked. So there's plenty of companies who are into this space. There's a lot of hype around it, obviously. For those of you who follow this space, you may be aware of the fact that at the DARPA Cyber Ground Challenge, which was held in conjunction with Black Hat, or same time as Black Hat this summer in Las Vegas, all 7 of the final teams used AI. All 7 did. So there's a lot, while there's a lot of promise, there's also a lot of hype around this as well. So Yoav, what are you seeing as far as hype is concerned in this space?
Yeah, in terms of hype, I think what we like the least is when entrepreneurs are just using the buzzword or the acronym as a marketing tool, to get the attention, whether it's the attention of investors or of customers. Anybody can slap the 2 letters onto their product name or description, but then when you dive deeper, I think in at least a third of the cases, we find that there's really nothing to back that up. We find that the engineering capacity required for AI is nowhere in the company, and that actually is the number 2 challenge, I think, for cybersecurity AI startup companies is access to talent. There's just not enough good practitioners out there. It's a very new space, AI and cybersecurity. I mean, arguably, I don't know what you would say, but it's definitely not. It's not even 8 or 10 years old, I would say. And the number of people really trained to actually do this right is a very small number. We look for startups in Israel. There's lots of great institutions in Israel, and plus the army to train people. But still, we're really only talking about hundreds of people in the whole country, maybe low thousands, that are really great practitioners. And so I think the thing that's most frustrating is, companies saying they do it, they don't really do it because they don't know how to. And then for us, our job is to fill it down, really find the ones that really have it, that really have the skill set and the people that can do it.
It's multiple skill sets that have to be put together.
You were right. It's Black Hat USA 2015, defeating. No, you can read.
Yeah, Black Hat 2015, Defeating Machine Learning, what your security vendor is not telling you. It's a good video. It's about 1 hour, so I would go watch that. Talia's giving me the hook here. We're out of time. I'll take one last question from the audience if anyone has one. No? Okay. Thank you for being here today. Appreciate it. Enjoy your day.